Hello everyone, Mr. Hein here, and here we are, 525. So you've learned the chain rule, you've learned the product rule, and you've learned the quotient rule. Now we're going to apply all these to find the derivatives of the other trig functions. Now, as of right now, you only know two. Recall that we know that if f of x is sine of x, the derivative of sine of x is cosine of x. And I'm putting it in these tables here because one of the problems you're going to do is going to have you put them in these tables as well and look for a pattern to help you. Try to memorize these. All right. And if the function is cosine of x, the derivative of cosine of x is negative sine of x. Now, what are the other trig functions to help you remember? So recall that if there's sine of x, well, the reciprocal of 1 over sine of x has a name, and that is equivalent to cosecant of x. Okay, so I'm going to add that to the table over here. Now note, this is that 1 over sine of x is not equivalent to sine to the negative 1 of x. And that gets a little bit weird because what we're used to seeing is you say, hey, that's on the bottom, so that's a negative power, so I could write sine of negative 1x. But with trig functions, it doesn't apply because a trig is not a polynomial, right? Trig functions in this regard, don't get treated the same way as polynomials. And what I mean by that, if I'm still lost, is like if I did 1 over x squared, you could write that as x to the negative 2. That's true. But with sine of x, be careful, sine to the negative 1x is not true. This right here is actually the inverse function. Inverse, which is not the reciprocal, the trig functions. And what I mean by that is, say, and a function was like, say you had to do sine of x equals pi. Well, if you wanted to solve for x, what you'd have to do here is to get rid of a sine, you'd have to do the inverse to both sides. Just like the inverse of multiplication is division, or the inverse of addition is subtraction. And that would make those go away, and you would then be able to do that in your calculator, the sine inverse of pi, which is not the same thing as 1 over sine. Okay, so just note that. So we have cosecant. We could do, let's see here, we could do 1 over cosine of x, and that's going to give us secant of x, and I'm going to add that to the table over here. And then we also have fractions where we could do sine of x over cosine of x, which is tangent x. I'm going to add that to the table here. And if you flip those, you could do cosine x over sine of x, and that's equivalent to cotangent x. So those are the 6 trig functions. There are 6 of them. And then there's a derivative for each one of these. And we already know sine and cosine. Your job is to use these rules to find all the other ones. Now, let's do one together so you can see how it looks. Let's say we want to find the derivative of secant x. So we'll do 2 together. So what's the derivative of secant of x? Okay. Now, using our rules, we can write this as the derivative of 1 over cosine of x, because remember secant is 1 over cosine. And then the quotient rule says the bottom times the derivative of the top, which would be 0, minus the top times the derivative of the bottom, all over the bottom squared. Simplifying this, that all goes to 0, so we're going to get positive sine of x over cosine squared x. And I'm going to split this up as sine of x over cosine of x times 1 over cosine of x. In which case, what I can write then is that this is equivalent to tangent x times secant of x. And the common way is, though that's right, the common way is they like to reverse those, so I guess we'll write it as secant x, tangent x. It's just more common to write it that way. And there you go. So if we come back to our table, if the function is secant of x, the derivative is secant x, tangent x. And notice how these derivatives are in terms of one of these 6, combination of these 6 trig functions. So in your work, you will be doing 3, 5, and 6 to figure out what those are, and hopefully you see a pattern with why I put these 3 over here: cosine, cosecant, and cotangent. Okay? So that's the first part of this. Second part I want to talk to you about in this video is this right here is an example where we're going to use all three rules. Clear off what I just did. That's not related to what I'm doing now. Of this function here. Okay. So if we wanted to take the derivative of this function, let's see how this works. Okay. So right away I see the chain rule because you have something to the 4th power. So chain rule first is the derivative of the outside. We bring that to the front, leaving the inside alone. So it'd be sine x over x minus 1, and then that'd be to the 3rd. And now if you're curious whether I didn't put that there, recall that sine to the 4th of something z is equivalent to sine of z to the 4th. So it's just a way of writing powers when we talk about trig functions. So what I did here is imagine that 4 being on the outside, bring it to the front, minus 1. Okay, so we have the chain rule, derivative of the outside leaving the inside, times the derivative of the inside. So now we're taking the derivative of sine of x minus 1, which that's chain rule again, because it's the derivative of the outside, which is cosine, leaving the inside alone, okay, times the derivative of the inside. So now we're doing the derivative of x over x minus 1. And that's the quotient rule. So then we have the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which would just be 1 as well, all over the bottom squared. And I believe that's everything. And we just have to clean this up a bit. So that's your answer, just in a very messy version, right? We did the chain rule, derivative of the outside, leaving the inside alone, times the derivative of the inside. And then when we try to take the derivative here, then that was the derivative of sine, leaving the inside alone, times the derivative of the inside. So then we had to take the derivative of x times over x minus 1, in which we had to do the quotient rule to get that. Very good. So I guess I didn't use product rule here, but that's okay. So cleaning this up a bit, what do we have here? Maybe I write this as 4 sine cubed of x over x minus 1, cosine of x over x minus 1. And over here, what would that make? That would be x minus 1 minus x. So those x's would cancel, and we would just have another times negative 1 over x minus 1 squared, in which, since that's all multiplication, I can bring that to the front. So probably the cleanest answer I'm going to get here is negative 4 sine to the 3rd of x over x minus 1, cosine of x over x minus 1, all over x minus 1 squared. And that is probably the closest thing I'm going to get for the derivative. And there you have it. So you can see up top, combining our rules we know to try and work on the 6 trig functions. And just recall that sine to the negative 1 is not the same thing as 1 over sine. The inverse is not the same as reciprocals with trigs. And keep in mind, sine inverse is the same as arc sine. Just another way of writing it, because you want to have a name for inverses. You don't just want to always just say the inverse, and the inverse is arc sine. Or arc any of these. That word arc is what makes it an inverse. And then from there, your work will be doing the derivatives of the other trig functions there. And then you'll practice using the 3 rules where I did an example here where there's a lot of chain rule and the quotient rule involved there. Hope that helps you. If you have any questions, do reach out to me, and good luck. Bye-bye.